My name is Hannes Westerman. I'm a researcher at the Cyber Justice Laboratory and a PhD student at University de Montréal. So the Cyber Justice Laboratory is a research center that explores the interplay between new technologies and the law. We're currently conducting the project Autonomy Through Cyber Justice Technologies, funded by the competition of the Social and Sciences and Humanities Research Council of Canada. Our project brings together more than 50 researchers and 45 partners dedicated to the use of technologies and artificial intelligence for the prevention and resolution of conflicts. And today, as part of the Blockchain and Smart Contracts Theme Week, I will present this presentation titled Understanding Smart Contracts. So let's get started. First, I will talk a bit in general about smart contracts and what they are and why they are useful. Then we will actually together build a smart contract. It will be a pretty simple smart contract, but a fully functional one. Then we'll use this as a kind of discussion point to see the advantages and disadvantages of smart contracts. And finally, I'll make a brief conclusion. So, what are smart contracts? Well, first of all, let's talk about where it all started with Bitcoin and the traditional blockchain. So the blockchain is this kind of distributed ledger that allows anyone to record transactions and thereby send money to other parties. So here's an example of how a blockchain could look. As we can see here, Alice sends 5 coins to Bob, Carol sends 2 coins to Alice. All of these are permanently recorded inside this blockchain, and it's impossible to change after it has been recorded. And by going through these transactions, you can see who has how many coins. So this can be used as a general method of payment. So this is completely decentralized. There's miners that are computers all over the world that compete to confirm the next transactions and receive a reward for this. And this means that there's no central authority that controls the progression of the currency, but it's all run by the participants of this network. It's also immutable. Once a transaction has been confirmed and there's been some transaction on top of it, it's extremely hard to change the previous transactions. And that means that it's essentially pretty secure to some extent, but the security depends on the security of your key, which is the way you access the Bitcoin network. So what are then smart contracts? Well, smart contracts kind of extend this paradigm. Instead of just storing transactions, in smart contracts, the blockchain can also store programs and run them. So in this example, for example, Alice installs a certain program that she has coded, and it is now part of the blockchain. And instead of just sending money to each other, participants can now send money to this program. So Carol here might send 20 coins to the program. And the program can itself send coins to other participants based on certain rules. So in a way, the blockchain here acts as a global computer that can run programs submitted by the participants. And the program can also hold coins here. Just like Bitcoin, this is very decentralized. The miners run the programs and confirm them, and they receive a reward for this. It is also immutable, so every transaction, every interaction that's ever happened with any of the programs can be traced and looked back in the blockchain, and it cannot be changed. So it's very deterministic in that way. And to the same extent as Bitcoin, it is secure, the system itself is secure, but there might be some caveats to that we'll get back to later. And today I'll be talking mostly about Ethereum, which is probably the biggest smart contract platform. It has its own currency, Ether, that's worth about $200 per coin nowadays. And unlike Bitcoin, which you can program a bit, but Ethereum is really made for programming. So it has its own programming language called Solidity. Programs inside of Ethereum can do essentially anything. They can receive cash, they can send cash, they can keep track of different actors who interact with it, and so on. They can also hold cash. In fact, contracts can even create other contracts and call and interact themselves with other contracts on the blockchain. So it's possible to create very sophisticated systems here. And whenever you want to run a contract, for example, by interacting with it, you will have to pay some gas. Now gas is kind of a currency that you use in order to pay for the execution of a certain program on the blockchain. but it's generally pretty cheap. A simple program to execute costs about 10 cents. Great, so that said, let's start building a smart contract. But first, let's set some expectations. By looking at this video, you will not learn to build secure smart contracts. I'm not an expert smart contract programmer. And we won't really be able to sell access to our smart contract or launch it in any way. It will be a toy smart contract designed to demonstrate how the smart contract programming works. There might be bugs in the smart contract, meaning if it was deployed, people could exploit it. And there also might be better ways of doing the things we're going to do with a smart contract. On the other hand, you will see the tools and the programming language necessary to build smart contracts. You will see a real-life example of a working smart contract. Again, this shouldn't be deployed to the blockchain, but if it was, it could handle billions of dollars in money, which is pretty cool. And using this smart contract as kind of an example, we will explore the implications of smart contracts. So let's get started. Let's take a real simple problem that I think many people have faced and see how we can help or remedy this with smart contracts. So the problem is a very simple transaction, such as selling your bike online. Alice wants to sell her bike, and Bob wants to buy the bike and pay Alice $200. Now Bob faces some risk here. What if he sends the $200 but never gets the bike? So maybe he asks Alice to send the bike first, but then Alice can't know if Bob will send the money. So a solution to this is to have a third party involved. That could be Carol, where Bob first sends $200 to Carol, then receives the bike, and once he approves that he has the bike and it's in good condition, Carol can transfer the money to Alice. So this could be seen as a very simple escrow service where Carol holds the money for the parties. So what we're going to explore today is if we can build such an escrow as a smart contract. As you saw before, we have three parties here: Alice, the seller; Bob, the buyer; and Carol, who is the escrow. So the question is, here of course they have to trust Carol, that she does her job, that she doesn't take the funds for herself, and so on. So let's see if we can, to some extent, emulate what Carol does with a smart contract. So the procedure would be this. Bob sends the money to a smart contract, and he shows Alice that he has deposited the money. Alice sends the bike. Once Bob receives the bike, she tells the smart contract to release the money, and the smart contract sends the money to Alice. This is if everything works ideally. Alice can know that Bob has sent the money and that he has that money, and Bob can be sure that maybe Alice won't get all the money if she doesn't send the bike. So if Alice does not send the bike, Bob would tell the smart contract this, not to release the money, and in our case, Bob would get 50%, Alice would get 50% of the money. This isn't ideal. This is not really something you would want to do in reality, because if Alice doesn't send the bike at all, she probably shouldn't deserve any money, but we'll use this as an example and then later talk about how we can expand this. So as you see, we need 4 functions for this smart contract. First, we need a way to save a new transaction. So Bob would go to speak to the smart contract and tell him that he would like to deposit some money. Here he of course has to save who he wants to send it to, Alice in this case, and how much money, and he actually has to send the money so that it can be kept by the smart contract. The contract then needs to keep a list of all saved transactions. If several people use this at the same time, there needs to be a way to tell these apart. So perhaps there should be some kind of key, as an end name, that Bob can call his transaction so it gets saved at a certain place. Then there needs to be a way to see a pending transaction for Alice. She needs to be able to go to this contract and ask it to show it the transaction by Bob so that she can verify that he has actually sent the money. And then there needs to be a way for Bob to unlock the funds. Either if he approves of the bike that he received, and the money gets sent to Alice, or if he does not approve, in our case, the money is split 50-50. So I've prepared 2 links. The first is the development environment, where we can post the code and then try it out. And the second is a place where I've posted the code that we're going to use in this tutorial. This segment will be pretty technical in about 10 minutes. What we'll do is we'll add the code to the development environment, we'll run it, and we'll start interacting with it, and after that we'll discuss the implications of how this works. I recommend for the moment that you follow along. We'll discuss the code at a very high level, and then after that, if you want to go try it out, you can take the code from the second link and try it for yourself. So let's open the development environment called Remix. Looks like this, and then let's open the link to get the code. The code is down here. So we'll create, here is the development environment called Remix. On the left here you'll see a list of files, and here we'll add a new file. I'm going to call it escrow service. Okay, and then you'll be faced with the code window here, and here we'll add our code. So this is, as you can see, not that long. It's about 40 lines, but it implements the features that we discussed before. First of all, it defines the data structure. It allows the contract to keep track of different transactions. Then here we have the function that allows the buyer, so Bob, to create a new transfer. He can add a key, that is a word, so he can keep track of the transaction, and the address for the receiver. And this function can receive money, so you can actually pay the contract through this function, which is important since he wants to deposit money along with this transaction. Then there's a function for Alice to get the transfer, to take a look, to examine that the right amount is there, and so on. And then there's a function for Bob to unlock the function, to unlock the transaction, so that the money either gets sent to Alice or it gets split between the two if he is not happy. Good, so that's the code, and now we have to translate it into computer code so that it can run on an Ethereum blockchain. The way we'll do this is to go here to the left to the compiler, and we'll click here compile escrowservice.sol. Perfect. Now this contract has been translated to computer code. And actually to deploy it, which means that we're putting it on a blockchain. So the computer has here made up our own Ethereum blockchain for us. We're not going to push it to the real one, but this is just a test environment where we'll have a couple of accounts to play around with. Mining will be very quick. Normally it would take a lot longer on the real blockchain. But it actually, in terms of the code, it would work exactly the same on the Ethereum blockchain. So this is a very good way to test out that the contract does what you expect. So you can press deploy here, and we see that under the deployed contract, we now have this escrow contract. And if you click on the little arrow here, you will see that there are 3 functions attached to this. First, the possibility to add a new transfer, then to get the transfer, and then to unlock the funds. So let's start playing around with it and see that it behaves as we expect it to. First, let's pretend that we are Bob, who wants to send a new transfer. Here, under account, there will be a number of different accounts you can switch between. You might not see this here, but if you click this little arrow, there'll be about 10 or so accounts that you can use. Each of them here have 100 Ether, but as I said before, this is just an experiment, so it's not real money. But we can pretend that it was and see how the contract deals with this. So let's pretend that Bob has the address starting with E9B, and Alice has an address starting with 105. What we want to do here is we want to make a new transfer from Bob to Alice, and we want to register this as a smart contract. So in order to do this, we need the address of Alice. So we'll switch to Alice here, and then we'll click this little button to copy the value to our clipboard. Great, and now we want to go back to being Bob. We can very easily switch between being different people here. So we want to create a new transfer. Click the little arrow here, and we'll see which information we have to provide. We need a receiver, and that will be Alice in this case. So we'll paste the address here. And then we need a key, and this will be the name of the transaction. So this is the name we can give to Alice so that she can verify that the transaction has been registered. And we'll call it, for the sake of an example, like. And next, what we also need to do is we want to add some money to this. So in value here, we can specify how much value should be attached to the next call. And we'll switch to Ether as the unit, and we'll add 1 Ether, which is about $200. But again, this is tar money. Great, so now I've set this up, and if you click transact here, this will get sent to the blockchain, and it will be registered, and it will be mined by the different miners, and the value should be added to the contract. And you can see down here that this has happened. Green means that it was successful. We can see a bit of information here. It said the transaction was mined and execution succeeded. And the output is success, is true. Perfect. So we now have a new transaction from Bob to Alice of 1 Ether called Bike. And if we look here at the how much Ether Bob now has, it's decreased by 1 since he paid this to the smart contract. So next we want to see if Alice is able to examine this to get the information about this transfer. So we'll switch to being Alice, which starts with a 105. We will go to the get transfer function down here, and here there's only one input we have to provide, and that is the key of the transaction. So what would have happened here is that Bob would have told Alice, I saved a transaction for you, it's at the key Bike. You can look it up if you want. So Alice, to verify this, she would go to this function, she would enter Bike, and she will call this. And she will now get some information about this contract. So she'll get a response. The response is first the amount. This looks like a lot because it's in very small unit, but this is exactly 1 Ether. The sender, she can look that it's actually Bob that sent this transaction. He starts with E9B, so this is Bob. And the receiver, which is Alice, starting with a 105 here. Perfect, so Alice now knows that the money has been deposited. She can be sure that Bob paid the right amount, and that he has a way to eventually send this to her once he gets the bike. So what you do now is to take the bike, package it, and ship it off to Bob. Okay, so only one thing left to do, and that is Bob now receives the bike, he takes a look at it, he makes sure it works well, and then he's potentially happy with the bike. Let's say he is happy. So what he now has to do is he has to go to the transaction and he has to approve it to unlock the transaction. So he does this with the unlock funds transaction. And he'll enter the key again, Bike, and then approve. In this case, he was happy, which means that he'll put true here. He approves that the goods arrived in a good state. And he will transact. And here actually this was a function that was triggered, and we didn't actually switch back to Bob, so we were now Alice. And so this was akin to Alice trying to unlock the transaction to herself, which is obviously not wanted. So the contract now tells us you are not the sender of this transaction. Great, exactly as we planned, but let's switch to being Bob to see what would happen if he unlocked the transaction. Transact, and now it succeeded. And we can look again at the data. It said transaction mined and execution succeeded. Perfect, approved. And if we now look at the balances, we'll see that Alice now has around 101 Ether. So she received 1 Ether from the smart contract. So this works, and as we saw before as well, it prevents Alice from approving transaction to herself. Let's try one more example, but this time maybe Alice doesn't send the thing. So let's say in this case, Alice wants to sell a watch. And again, Bob wants to buy it. So we'll register a new transaction. We'll make sure that we are Bob first. And then we'll make a new key that we call watch. The receiver is still Alice, but this time we'll add 10 Ether. So we will transact. It succeeded. And if you now look at the balances here, it looks like Bob only has 89 left. Alice still has 101. She hasn't yet received the additional transaction for the watch, but it has now gone to the smart contract, which now holds those 10 Ether. Alice again would want to see that the money is actually being deposited before she sends it. She enters watch, she calls it, and she receives the information that there are 10 Ether deposited for her address at this account. But Alice now sends the watch to Bob, who takes a look, and there's something wrong with it. I think that maybe it's cracked, or maybe it just never arrives. So in this case, he doesn't want to unlock the money. What he does instead is he enters the key watch. I have to make sure to switch again so that we are pretending to be Bob, which we have. And in this case, he does not approve. False. Let's see what happens now. So now press transact. Again, the execution was successful. But now, if we look at the balances, we'll see that Bob actually got back a number of coins. So he's now again at 94, and Alice only received 5 extra. So that was as we planned. Again, there's some room for improvement here, which we'll discuss later. But as you can see, with only about 40 lines of code, we were able to define this contract that has pretty complex behavior, and it's also able to handle real Ether. So now we deployed it to our test chain here, but if we deployed it to the public chain, people could interact with this program and start using it immediately to work as an escrow service. So I think it's pretty cool how with only 40 lines of code, you can build this contract that's able to handle financial transactions. And the code, if you look into it, is not that complicated. It's actually pretty straightforward to create these contracts, although you probably want to add some stuff to make it more resilient to bugs and potential attacks. So let's talk a bit about how we could improve this. First of all, obviously it doesn't really make sense that if the buyer is unhappy with the good, 50% goes to the seller still. Perhaps the seller would just never send something and still get 50%. So it would have made sense perhaps to integrate a third party into the smart contract. So we'd add another address, which would be a person that is an independent party. And they would then perhaps, with an ODR process, an online dispute resolution process, they could look at what happened, what was received by the parties, and then say what should happen to the funds. Another important thing maybe there's a bug in this contract, and maybe we want to wait to terminate it if it doesn't work, so that the person who created the smart contract would be able to cancel it. Or maybe they want to update it to improve something. And also what we could add is the ability with a smart contract to take a cut for itself. Perhaps 1% of the transaction value will go to the smart contract. So this would be a way of launching a business based on the Ethereum platform. So what should we take away from this example? This was only one example. I'm going to go through some more examples, but let's discuss what this can tell us about the smart contract platform. First, let's go through some other examples of uses for the Ethereum blockchain or other smart contract blockchains. So this, for example, Steemit. It's a cryptocurrency platform that is a bit like YouTube in that people can upload videos. But the way this works is that if you like something, they will actually receive some cryptocurrency to finance them. So there's a way of directly supporting creators on this platform, all based on smart contracts. Here, RideX was a suggested approach to create a decentralized Uber. Instead of having an Uber app that talked to this centralized company, it would all work on smart contracts. That is, you would post that you want to get picked up and at which location, a smart contract would assign a driver to you, and they would then come pick you up. So this way there wouldn't be a middleman, but you would speak directly to this smart contract, which would hopefully make it cheaper and make more money go to the drivers. There is Slock.it, which is a platform that connects devices to the blockchain. And this is meant to be for sharing things. So you could, for example, have a car that was connected with one of these special locks that connects to the blockchain, and via the blockchain you'll be able to unlock the lock so people can use the car. And this could be used for renting or selling things. Democracy.earth is a very ambitious project that aims to create a peer-to-peer system for democracy. And the idea here is that people would directly be able to vote, and be very transparent, and this would be the building blocks for a censorship-resistant democracy on the internet. CryptoKitties is another example that's actually built on Ethereum, and that is a game. So on the blockchain, this will issue CryptoKitties that can be traded and play different games with. and these have been very successful, and some kidneys have been sold for several thousands of dollars. And finally, the DAO, the Decentralized Autonomous Organization. This was a huge crowdfunding project that was launched on Ethereum, and there were some things that happened to it. We'll get back to this later, but the idea was to create a decentralized fund where people could invest in proposals and vote for which proposals would be accepted. But we'll get back to this later. So, what are the advantages of using smart contracts over using traditional things? Well, there's actually quite a lot of advantages, and it is very easy to get started. As we saw before, it only takes about 40 lines of code for something that's able to accept transactions and react based on transactions. So if you want to create a company or a payment platform, this would be an easy way to get started. It also has a global reach. Anyone, anywhere can interact with this Ethereum platform, so it would work across any country. There is no interpretation going on. Everything that happens to the money happens because of the code. So in theory, the terms of these contracts are extremely clear. Anyone could read the code and understand what will happen and how the contract will work. Now we'll get back to this later because there might be some issues with that. It's also a permanent record of all transactions with the smart contract. So for auditing processes or for tax filing, perhaps it would be very useful to have a smart contract, as there's no need to create a separate logging platform or archiving executions, because everything that happens publicly on the blockchain, and anyone is able to see what has happened. The execution is very quick. On the Ethereum blockchain, it takes about 2.5 minutes or it's very quick for a block to be confirmed to. So within minutes, you'll see that something has happened based on the smart contract. There's no human involved. So if you pay something and something is supposed to happen because of this payment, this will happen very quickly. It's also secure to some extent, since this is all controlled in a decentralized way based on mining. It's very cheap. There's no need to hire humans to manage these contracts, but it's all being done automatically in the background, and running contracts does cost some money, but it's usually not that much. So many of these smart contracts are being used to cut out the middleman. That is, instead of having a middleman like Uber or Amazon that manages transactions, and so these are platforms where someone can put up goods and other people pay for them, but a big chunk of the revenue goes to the middleman. And the idea with many smart contract ideas is that we don't need the middleman anymore. The smart contract platform can manage this by itself, which would make things cheaper and also more of the money go to the creator. But there's also some issues, and I thought we'd go through some potential issues with smart contracts next. So one is security. What does this mean? Well, mining, as we talked about, is very secure. It's basically impossible to reverse a transaction after some time has passed over it. But the security depends on some factors, because while the blockchain itself is very secure, outside of the blockchain there's always a need for people to interact with it. And usually on most blockchains it's done with a secret key. And this key is your identity. So if you lose access to this key, or if someone else gets this key, then they can do whatever you would be able to do on the blockchain. And for example, if you get hacked, people could just take your money and transfer it away, and there's no way to reverse the transactions. And if you lose your key, the same happens. The money just sits in your account, but nobody will ever be able to access it, since it's impossible to guess someone's key. So if you, for some reason, lose access to this key, the funds will be gone forever, unfortunately. Further, since before if people are hacked, the hacker might be able to take some of their money, but people often have recourses. They can go to their bank to get back this money. But on the blockchain, this isn't really the case. If someone gets access to your keys, they could take all of your cryptocurrency. And if people start storing large amounts of money, hundreds of thousands of dollars in the blockchain, there's a massive incentive for that person to be hacked. And hackers might specifically target that person to get access to those funds. Now, computer security is very hard. Even huge companies occasionally get hacked, so this means that individuals might actually be compromised as hackers specifically target them for their cryptocurrency. There's also the need for oracles. So while the blockchain itself is very secure, there has to be some interface with the real world. The blockchain can't really go on the internet and look something up, or it also doesn't know if the package you receive, for example, is empty or fraudulent. So something has to tell the blockchain that this occurred. And this, while the blockchain is distributed, this would be a single point of failure. So that individual could get hacked, or maybe they could be fraudulent. So there's a need to trust these oracles. There's some ways around this by having multiple oracles acting in a certain way, but that's always a weakness in these schemas. There's also another weakness, and that is that it's sometimes a bit unclear what is actually the contract. So let me explain. What is a contract when you do a contract with someone else in the real world? Usually the courts would say it's not necessarily what it says in the written contract, but it's what both people intended while signing this contract, kind of the idea of the meeting of the mind. And if both people are happy to step away from these terms, then that's not an issue, because the contract is what is the meeting of the mind between the people. This is not really how it works on Ethereum. The contract is here the code. So even if the people didn't intend for something to work in a certain way, if that is in the code, that is how it will work. And this could lead to fraud, for example. If one person tricks another person saying, this is what will happen in this smart contract, but that's actually not what will happen, then that is a significant issue. The terms could also be really hard to understand. For a normal user, it's really hard to go into this Ethereum smart contract to read through every line of code and to exactly understand how that works. So even if there's no fraud involved, the consequences of the code could simply be unintended. They didn't really understand what's happening. What's important to note here is, if there is a mistake, there's no way for a court to fix it. And that is because the contract or the blockchain is immutable. Nobody can go in and change something. So if a contract, for example, accidentally behaves in a way that locks away funds forever, nobody can tell it to unlock that without basically affecting the entire blockchain and convincing all miners. So here the immutability actually becomes an issue. Sometimes you want contract terms to be flexible, and on the blockchain they're really not. It's also the issue of anonymity. Normally if you do a contract with someone, you usually know who they are, and if you sue them, the court knows who to go after. And how to get the funds back, perhaps. But on the blockchain, the actor you speak to might be completely anonymous, so that could make enforcement very hard. It could also be in a completely different country. That brings me to the next issue, which is bugs. And that is that even for people who intend to make the most secure program and who do not try to trick the other person, there could be issue of bugs, that is, small mistakes in the programming. The entire happening of what will happen on the smart contract platform depends on the quality of the code of the smart contracts. There could be bugs in this code, meaning that funds could be stolen, or funds could even be locked away inside the smart contract where no one has access to them ever. And as we discussed before, it's very hard to verify whether there's bugs in the code. There can be bugs that even programmers who read over it many times just completely miss. And here we'll get back to the DAO. That was, I think, one of the biggest examples of a bug in a smart contract that caused huge losses or big issues. DAO was launched by the company behind Slockit, and it stands for the Decentralized Autonomous Organization. The idea was to create a decentralized fund in 2016, where people could buy into the fund and then receive a token that indicated their share of ownership, and then based on this they could vote for different proposals on the blockchain. So it was extremely successful. It raised 150 million US dollars in Ether at that time. That represented almost 15% of all Ether that was in circulation. But there was an issue. There was a small bug in a part of the code, and that the DAO was hacked. $15 million worth of USD was stolen. And again, because of the blockchain, there was in theory no way for people to get this back. It would just go to the hacker. So there was a discussion here, should this be tolerated or should the code be reversed? And there was a post on a file on a sharing website that claimed to be from the hacker. It's a bit unclear if it actually was, but he made a pretty interesting argument. He said that in the terms of the DAO, it says that the terms of the DAO are set forth in the smart contract code. Nothing in this explanation or terms or in any other document or communication may modify or add any additional obligations or guarantees beyond those set forth in the DAO's code. So he's said essentially, yes, there was a bug, but since the terms of the DAO are only the code, this wasn't really a bug. This was part of the initial contract. And he claimed that people who wanted to take back the money were actually stealing from him, since he had the right to this money under the code. What happened in the end was that the Ethereum creators decided to make a hard fork. That is, they decided this was illegitimate, we want to reverse this specific transaction where the hacker stole that money. So with a lot of the miners behind them, they created a modification to the platform. Now remember, the Ethereum is completely decentralized, meaning in theory nobody should be able to modify what has once happened. But in this case this was possible because most of the miners on the platform agreed. So the new version of Ethereum was actually one where this specific thing was changed. But many people didn't like this, and they said it undermined the idea of smart contracts. So this actually led to a hard fork, meaning there's now two versions of Ethereum. Ethereum, the new version where this transaction was reversed, and Ethereum Classic, that is the old version, that didn't accept this change. And both of these are actually tradable right now on different platforms. Next, let's talk about compliance. Even if these smart contracts sometimes see themselves outside of the law, there are of course many laws that apply to them, and complying with these might be an issue. One compliance issue, for example, is tax. Obviously, if you make money, you have to pay tax in most jurisdictions, and this could be hard for tax authorities to find, since it's very easy to create an anonymous account on Ethereum, and people could transfer money there. And even some smart contracts are acting like corporations, which would mean to lead to an even more complicated tax regime. Now, of course, people can put the work into to be tax compliant, but it's possible and probably quite easy on the Ethereum blockchain to not pay tax on gains, which would be against the laws of many countries. Second, there's many legislation for anti-money laundering. That is, you have to know who pays money to who in order to prevent terrorists from laundering their money, for example. This is again very tricky on the Ethereum blockchain. Since on Ethereum, actors are by definition represented only by their key, which is kind of a pseudonym for who they really are. And if someone wants to transact with a smart contract, there's no real way of telling who that person is. That might be another legal issue. So the question is, what happens if a smart contract does illegal activities? For example, someone could upload copyrighted material to a smart contract, or sell drugs using that smart contract. Again, once a smart contract is launched, the creator usually doesn't really have control over it, so people could use a smart contract in that way, and nobody would really be able to stop it. If, for example, someone hosts an illegal book on a website, a copyrighted book, there is often some ways that you can go after that person to try to get their website taken down. On the blockchain, this is by definition impossible. Once it's part of the blockchain, it will forevermore be part of that blockchain. And you would have to really affect all miners in order to take this down. That could be very problematic. Fourth, as we discussed before, there are many cases where a court might tell a corporation to do something, and the corporation then has to comply. But again, with the blockchain, it doesn't really work that way. A contract is completely autonomous and nobody can affect it beyond what's defined in the code. So this could be very problematic. If a court orders a smart contract to do something, there's no way to make it do that without affecting all miners again, or even shutting down the entire blockchain. And fifth, securities regulation. Many things in smart contracts might seem like securities. That is, they give the owner the right to vote or do something other and earn money based on this. Now there's a lot of securities regulation that defines how this can be done in most countries with regular systems. There are things such as insider trading that have to be prevented, and prospectus that you have to publish really detailed what an investment does. And this is, again, really hard to implement on the blockchain, and it's possible to issue securities or things that seem like securities on the blockchain without caring about these regulations at all. So that's another big legal issue where compliance of the smart contracts might be difficult. Next, we have to talk about liability. If you have a corporation, there is kind of a corporate veil. That is, investors in a corporation are usually protected from liability of the acts of that company. So they can only lose what they have invested in that company, but their personal investments are safe, and that makes it easier to invest. You can invest in a company today without fearing that that company will go bankrupt, and people might come after your personal belongings for that debt. But it's not really sure if this works in smart contracts. Corporations are usually defined in a very specific way, and it's a bit unclear if smart contracts live up to this. Probably they don't, since corporations have to be registered with the state. So perhaps a state will therefore see a smart contract that follows these kind of things, where people invest together and earn revenue based on these investments, as a general partnership instead. Now, in a general partnership, the liability is not on the company itself, but it is actually on the participants. So perhaps, without knowing it, people who invest in these kind of sophisticated smart contracts actually end up liable for any illegal activity that smart contract does. It could be very surprising and a very expensive mistake for many people. It could also be the issue of liability. Who is then liable? Is it the participants, as we had said before? Is it the creator of the smart contract? Remember, we might not necessarily know who this creator is, and once they've launched a smart contract, they have no control over what it does after that. Or is it potentially the entire network? Could you say that all miners on a network are somehow liable for every single smart contract that is run upon it? This would make mining completely infeasible and kind of kill these things. Also, the issue of legal personhood. Corporations have assets, and that is things that they can manage things, they can be liable in contracts. Not really sure if smart contracts can do the same thing. They are based on the blockchain, and they don't really have legal personhood assigned to them in that way, perhaps. Many people have started to create kind of link companies that link the smart contracts to the real world, but it's a bit tricky and something that has to be figured out in order for smart contracts to become viable as alternatives to corporations. There are some issues with smart contracts, some legal difficulties. Next, I'll briefly conclude what we've talked about. So we talked about what smart contracts are. They are essentially blockchains where the content is complete computer programs that are programmed by someone. People can then interact with those, and the smart contract can interact with the rest of the network. We built our own smart contract to see how it works, and we built a smart contract that is able to take money from someone, and based on something that happens, send this money to different participants. Then we talked about some advantages here. It was very easy to create this, it was very quick, and it's secure to some extent. But we also mentioned some significant disadvantages. I think smart contracts are really interesting. Normally, the contract that we sign, the contract is the meeting of the minds, what people consider to be the contract. But smart contracts, in this world, the entire content of the contract is actually the words used to write this, or in this this sense, the computer program. I think this is really interesting. It's a new way of looking at contracts, if it even is a contract, and I think it gives a lot of people, it gives us an opportunity to think about some issues affecting the law and vice versa. I mean, there are some things that can be learned from the blockchain towards the law. One really interesting thing is how transparent these contracts are. If you properly understand the code, you can exactly see what will happen, which makes it very predictable and very quick, something that we might not have in the court system, where issues can sometimes be complicated and not really transparent for the public. But I also think people on the blockchain side can learn a lot from law. And we saw that in creating smart contracts, we often need to consider what happens, for example, if someone sends money to someone else, but there turns out to be something wrong with the transactions. It's very hard to reverse this. So in some sense, in order to make the blockchain a very feasible platform, you would have to recreate some legal parts inside this blockchain to re-enable those structures. That was it for me. Thank you so much for listening. I hope you found it interesting. For the next activities on our blockchain week, you can go to savajustice.ca, and I hope you stay healthy and look forward to seeing you soon. Thank you.